Okay. All right. So if you look here, okay, at the beginning of this, so remember this right here on the left, talking about just the derivative in general today. So again, it should be kind of a breath of fresh air, a reprieve for us. All right. So this whole big formula right here, if you remember, this is what we call the difference quotient. Now, it's how we found the derivative before we taught you the shortcut for the derivative. Okay. If you remember though, when we did it in first semester, these delta x's were h's. So it was like x minus h over h. Like we had h's there, not delta x's. They're the same. Okay. Same formula, just a different character there. All right. So basically we would, if we did the difference quotient and found the limit of the difference quotient, okay, it ended up equaling the derivative. Okay, so what we would do is we would have to go through and do all of this, plugging in x plus h everywhere in for x, and then subtracting and then dividing by h, and we would simplify. And y'all may not remember, but when we first started doing the derivative, those were some very long problems. They took a lot of space because we were plugging all this in, and then we would get down to a final answer, and we were just like, oh, okay, we've accomplished it. And then literally like 3 days later, I was like, and here's the shortcut to the derivative. And everybody gets all mad, right? Because why didn't you show us this to begin with? Okay. All right. So what you're going to recognize on example number 1 is if you compare example number 1 to the difference quotient that's right above it, you can go ahead and tell me, what is our f of x? What is our actual function? So what is f of x for this problem? Yes, it is the cube root of x squared. So because we remember the difference quotient, you don't have to work all this out and find the limit of this. We can, okay, but we don't need to, because we can recognize that we know what our f of x is. Once you know f of x, now we can just do our regular derivative process. Okay, so I am going to rewrite f of x to the cube root of x squared as x to the 2/3. Okay, remember the number outside is on the bottom, inside's on the top. All right, so now we're just going to use our derivative rule. So if I want to take the derivative of this, I'm going to use what rule? Power rule, the power rule. So f prime of x is going to be, bring that 2/3 to the front. -1/3. Subtract 1, that gives me -1/3. Now, again, on your AP exam, probably completely acceptable if you're doing something to go from here, but I'm not going to leave it with that -1/3. I am going to move that. So the 2 is going to be on top. The 3 is going to stay on bottom. And then this x to the -1/3 is going to move to the bottom. So it's just going to be the cube root of x. So there is our derivative. Okay. So again, you could have done this the long way with the difference quotient.
What was the point of us learning this?
It teaches you why the derivative works.
Okay.
All right, so now, big 3, rules for differentiation. Okay, the first one we have is the product rule. Okay, it was the very first one that we learned. Okay, which means product rule is the, how do we do the product rule? Derivative of the first times the second, right? Plus the derivative of the second times the first. Okay, derivative of the first times the second plus the derivative of the second times the first. Now, quotient rule is where we're going to minus, right? That is Hody high. Okay, so remember, this is high. This is ho. All right, so ho, which would be h of x in this situation, d high would be the derivative of g minus high d ho all over ho ho. All right. So product and quotient are not insanely difficult for us. They were perfectly product, quotient, and power. All three of those y'all are pretty good at on the regular. All right. Now chain, sometimes we get a little iffy on just because we forget to do it. But remember, chain means you've got to do the derivative of the whole function. So g prime of h of x times, so that's our donut, and then our donut hole would be the derivative of the inside. All right. Are we good? Okay. So here's what's about to happen. All right. Here's what's about to happen. We're going to work through like these four, A, B, C, and D. And then when you flip the page over, I'm going to give you some time to work on the remainder of these. They don't get super difficult until about letter H and letter J. Other than that, they're not super duper difficult, including the four that we do. All right, so let's start with number one, or letter A. All right, so we're just trying to find, it does say work in small groups, find derivative. We're going to do the first four together, and then, like I said, you'll work on the other ones. Okay, so if I do the derivative of the first one, it's going to be pretty simple, right? So power rule, so bring the 3 down, 3, drop that by 1, bring the 1 down, drop that, we're done. Pretty simple. All right. So now, how am I going to rewrite letter B first? Yes, sir. It would be x to the power of 1/5.
Then the derivative of that would be 1/5 x to the power of negative 4/5.
All right. So then g prime of x, y'all. G prime of x. So bring the 1/5 down, and then subtract, and your right turn it is negative 4/5. Okay. So again, I'm going to clean that up without a negative exponent. So that 5 is going to stay on the bottom, and this whole thing is going to come to the bottom. So it's going to be the 5th root of x to the 4th. So your exam is not super picky about it. Like you're going to see when we get to the backside of this, there's a lot of places where I just stop. I don't find common denominators. I don't try to get everything, just because when you start moving further into that, there's way more room for error. And so if they don't specify, write it as one fraction or any specific instructions, I stop as early as I can so that there's not as much error, possible error. Okay. All right. Number 3, or letter C. Okay. So I'm going to rewrite this. Now, there's obviously a couple of ways we can do this. Okay. But I am going to go ahead and rewrite this. I can simplify that bottom. So if I do 3x quantity squared, what does that give me? 9x squared. Is everybody good there? All right, and we know that pi is a constant, right? And so is 9. So I can really rewrite this as pi over 9. Now, you can do that times 1 over x squared. Or if I want to just use the power rule, I'm going to rewrite that x as x to the negative 2. Once I get it in this form, the power rule is way easier. Yeah, you could do, you could do quotient rule from the beginning. But I'm saying if you did that, the derivative of pi would obviously just be 0. So those are going to cancel. All right. So then if we look now, if I do the power rule from here, so I'm going to pull the negative 2 to the front, right? So it's going to be negative 2, pi over 9 times x to the negative 3. So then again, if I want to get rid of that negative exponent, the negative 2 pi would stay on top, and the bottom would be 9x cubed. All right, so the first one now, there are two ways that you can do letter D. I am going to do it. Which way do I want to do this? All right, let's do the product rule first. Okay, let's just do the product rule first. Okay, so product rule is derivative of the first, right? So what's the derivative of 3x plus 5? All right, so 3 times the second, x squared minus 2x cubed, plus the derivative of the second. Mm-hmm. Good job. Times the first. Okay, so that's using the product rule. So then from here, we're going to start simplifying these things out so that we can kind of clean this up a little bit. All right, so that's going to give me plus 6x squared. 2x times 5 is plus 10x. Negative 6x squared times 3x is negative 18x cubed. And negative 6x squared times 5 is negative 30x squared. All right, and then our last step would be to combine like terms. So I'm going to do cubes first because that's our highest exponent. So negative 6 minus 18 is going to give me negative 24. Then I've got my squares. So 3 plus 6 is 9. 9 minus 30 is negative 21. And then the 10 just tacks on to the end. So that would be our answer. Now, that is one way to do it. The other way would be you could have distributed from the beginning. So if I distributed 3x plus 5, so if I distributed here, that would give me 3x cubed minus 6x to the fourth plus 5x squared minus 10x cubed, right? So then I would have negative 6x to the fourth minus 7x cubed plus 5x squared. So there's that. And then we would just do the power rule for that, right? So bring this down, negative 24x cubed minus 21x squared plus 10. Still gives you the same place. Okay, so either one will work. I did the product rule just because I wanted to practice the product rule before we got to the back side. Okay, all right, so flip it over for me. All right, so let's go ahead and talk about what you're going to use on each one of these before you get going. And then, like I said, I'm going to let you work on them. All right, so for letter E, what are you going to have to use? You're going to have to use the quotient rule, right? All right, for letter F. That's just straight derivative, right? There's no chain rule in there. There's no, I mean, you take the derivative of the first, derivative of the second, you're done. All right, now for G, we're going to have to use you're multiplying, right? X squared times e to the 4x. So that's going to be product. What about H? All right, it's product and chain, yes. I is also, it would be power and chain, right?
And the J would be.
All right, so J is quotient, but within the quotient, you're also going to have to use chain. All right. So take a few minutes, start working through those.
Okay, wait. Oh, the one on the top of the wall.
Do what?
Low, low, high.
All right, so let's look at the first couple. Okay, so if I do quotient rule here, right? I'm going to have J prime. All right, so ho D high minus high D ho. over ho ho, right? So then if I distribute here, so this is going to give me 6x squared, right? Minus 15. And then this is like a minus 4x. So if I do minus 4x times 3x, that's negative 12x squared and minus 4x. So that takes me to 6x squared minus 12x squared is negative 6x squared minus 4x minus 15 all over. And I just left this as it was. So that was my answer for letter E.
For F, is the answer pi over 2 cosine theta plus sine theta?
It is.
Dang, I'm playing, bro. Number 5.
All right. It is. All right, so for k of x over here, so k prime is going to be pi over 2 cosine theta, right? Minus negative sine theta, which turns into positive. So pi over 2 cosine theta plus sine theta. All right, so everybody good? E and F? All right, so for G, all right, so you started by doing the product rule, right? So P prime. So derivative of the first, so derivative of x squared is going to be 2x times the second plus the derivative of the second. So the derivative of E is in fact just E, but you got to do that times the 4 because of the 4x. So it's 4e to the 4x times x squared. So yes, you absolutely could leave your answer 2x e to the 4x plus 4x squared e to the 4x. That is completely acceptable. Everybody with me? 100% acceptable to stop there. Okay. However, what I did do now, the only reason to do this would be multiple choice, making sure you're able to recognize the different forms. Okay. They both have a GCF of 2x e to the 4x. So I could factor out the 2x e to the 4x, which will leave me with 1 plus 2x. So this only reason to have to do that would be if it's a multiple choice question, just to make sure you know they're both there. Okay. All right. So letter H, again, is one of the ones that gets a little dicey.
It's the first half equation, and that's divided by 3 to the negative 2. The denominator is 3, power to the third, and x plus 2 to the second.
All right. It is 10x. And the denominator should just be 3x plus 1 to the 1/3.
Okay, yeah, you go with that. I was not there.
Okay. All right, so let's look at what we got first. Okay, so obviously I don't want to do this from the radical form, so I want to go ahead and change that radical into a fractional exponent, right? So the 5x is going to stay 5x, and then I'm going to rewrite 3x plus 1 to the 2/3 power. Okay. All right, so now we've got product here, right? So if I do product for this, so q prime, so derivative of 5x would just be 5 times the second, so 3x plus 1 to the 2/3 plus, all right, so here's where we have to do both because the derivative of this is going to be power rule first, so 2/3 3x plus 1. If you subtract 1 from 2/3, you get negative 1/3 times, what's the derivative of 3x plus 1? 3, right? Times the first, which is 5x. So derivative of the first times the second plus this is the derivative of the second times the first. Is everybody with me so far? All right, so what you're going to recognize is that this 3 and this 3 do what? They cancel each other out. Boom, boom. Okay, so now leaving the first one the way it is, so it's just going to be 5 3x plus 1 to the 2/3. All right, but the second one now, I'm going to do this 5x times this 2. What's 5x times 2? So 10x over 3x plus 1 to the positive 1/3. Now, y'all, what I'm saying is you can stop here. I don't have any negative exponents. They don't care about the fractional exponents. You don't have to rewrite that as 5 square root of 3x plus 1 cubed over the cube root of 3. You can, but you don't have to. Okay. So this right here, again, is completely acceptable. All right. Or if you did keep simplifying, you could have, and there's a ton of different places in between here and the next answer I'm giving you. There's like several steps that it also could be. You could have 25x plus 5 over the cube root of 3x plus 1. Okay, I'm not going to go through how to get there because this right here is perfectly acceptable. Okay, again, on your AP exam, don't spend a whole bunch of time trying to simplify things unless it's a multiple choice question and your answer isn't there. Then we do have to figure out how to get from our answer to one of the answers that's there. Okay. All right. Letter I. Okay, so if we do product, right? Or power first, sorry. So this is R. So R prime of x. So power means the 2 is going to come to the front, right? So ln of x plus 5 times. So what's the derivative of ln of x plus 5?
Isn't it like get rid of the whole LN of the weird equation?
You do get rid of the ln. It just becomes, anybody remember? It's just 1 over x plus 5. Did I know? All right, so if I wanted to simplify this and just make it a little bit cleaner, I can do 2 times 1 times, I can do all of this times 1 and just put the x plus 5 as my denominator. So 2 ln x plus 5 all over x plus 5. All right, so now letter J again is the most difficult one we're going to have. You can't cancel out x plus 5s because that the top x plus 5 is tied to that ln. So it's an actual value. All right. And then y'all, literally after letter J, the rest of these notes are pots and tots, things that are super duper familiar. Okay. And not that this is not familiar. We just haven't dug this deep into derivatives in a while. Okay. All right. So again, couple of ways you can do this. Obviously, I'm going to have to use what rule? All right, quotient and chain. Yes. Okay. So I'm going to go ahead on the top, though, and I'm going to distribute that out and make that one term. Because otherwise, I would have to use product, quotient, and chain. That's going to be hideous. Okay. So if I distribute this out, that eliminates that product rule. Okay. So if I do this, that's going to give me x to the 4th minus 3x cubed. Everybody good there? All right. All over just the x. Oh, wow. What was that? X squared minus 9. I have no idea what happened to my radical there. Holy cow. Okay, sorry. That was hideous. All right, so W prime. All right, so how can I rewrite this? Yeah, so that's how I'm going to do that. Okay, so ho would be x squared minus 9 to the 1/2. All right, so d high makes that easy. What's the derivative of this? There you go. Minus high. All right, so d ho. So power rule first, right? Bring the 1/2 down.
1/2 times x, 1/2 x squared minus 9
Negative 1/2. Times, now what's the derivative of x squared minus 9? There you go. All right. So now there's everything you need. All over. All right. Now the good news is the bottom, that does simplify a little bit without you having to do much work, right? Because if you square a square root, what's going to happen? It just goes away. So our denominator is going to turn into just what's under the radical? X squared minus 9. Yes. Okay. So let's look at the top. All right. I'm going to leave this alone. Okay. I'm going to leave both of these alone, actually. So I'm going to write that as the square root of x squared minus 9 times 4x cubed minus 9x squared. Okay. Minus. What's up?
Let's say, why does the denominator square root of squared so x squared
Right here.
Yeah, why would that not just be x squared minus 9 squaring the radical?
Isn't that what I just said? Like we're just going to write x squared minus 9 as the denominator. You're good because you're wrong. When I square that square, that is going to go away. So my next step, you're good. No, that next step, I will write it out as just x squared minus 9. All right. So now over here, I'm going to leave this x to the fourth minus 3x. What am I? Oh, no, I've got to multiply that times. Okay, what's going to happen to these two x's? We'll do that first. What happens to this 2 and this 2? They're going to cancel, right? Okay, and then I have an x left. Is everybody with me? So I'm going to put that x with these. So that's going to make that x to the fifth minus 3x to the fourth, okay? All over, because this is a negative, right? The square root of x squared minus 9. All over x squared minus 9. Now, again, there is no reason. Now, I could go through and multiply by the square root of x squared minus 9 to try to get a common denominator on the top. There's no need. You can literally stop right there. Okay, so the problem with that is in your mind, there's no way that's a final answer. It's just too complicated, okay? But just remember, once you do your steps, once you do your product, your chain, your power, your whatever, quotient, any of that, everything after that is just a simplification. So if it's not multiple choice, there's no need to go through those steps and risk making an error. Okay? All right. So now we're going to get into the fun stuff. All right. So the minute y'all see the words, find the equation of a tangent line, we better be thinking pot and the sot. Okay? The minute we see equation of the tangent line, we're thinking pot and sot. All right, well, pot is easy. They gave us the x, so to get our y, we plug that in, right? So f of 9, so the square root of 9 plus 1. What's the square root of 9? 3 plus 1 is 4, so our pot is 9, 4. Is everybody with me on finding the pot? All right, then the slope of the tangent line, the SOT, we have to find the derivative. So I need to find the derivative first. Well, remember, we can rewrite this as x to the 1/2 power, right? So if I find the derivative of x to the 1/2, it's going to become, there you go. And the 1 goes away. So that's the same thing as 1 over 2 square root of x. Only did that because I do have to plug in a number. You do. Mm-hmm. So if I plugging in 9, right? So 1 over 2 square root of 9. So that's 1 over 2 times 3, which is 1/6. So I've got my pot. I've got my SOT. So now we can write our
Y minus 4 equals 1/6.
perfect. Good job, Trenton.
Great job. Thank you.
Everybody with me? Okay. So found the pot. Found the SOT. Write your equation. Okay. All right. So y'all go through and do letter B. Find the pot. Find the SOT. Okay. And again, before you find the SOT, you're going to want to rewrite that without that in the bottom. You're going to want to rewrite this as 1/2 x to the -2. It's just easier to take the derivative that way. Otherwise, you can do it this way. You would just have to use what rule? Quotient, yeah. You'd have to use quotient if you did it that way. This way I can just use power and I'm good. Okay? All right, so go ahead and find your pot and your SOT here. Go from there. Do what? What you got? What you got for your pot?
1 1/2.
Everybody get 1 1/2 for our pot?
And then the thought would be -1/4.
I got negative. I got negative.
All right, well, hold on. Let's. Trenton said, obviously, you're wrong. All right, so that gives me 1 1/2. Is everybody good on the pot? All right, so then SOT.
Oh, no, it should just be 1.
No, it should be negative. So F prime first. All right, so if I pull the -2 down, right, that turns to a -1 here, correct? So -1. You just multiply by 2 on the denominator. I got you. Okay, so it should be negative x to the -3, right? Which is the same thing as -1 over x cubed. Ultimately, it's -1 over x cubed. So now if we plug in 1, you get -1. So yeah, y minus 1/2 equals. And again, there's no need. I mean, you can make that -x plus 1. There's no need to do that. Yeah. Sure can. All right, last page. Last page. You know this one? You're up. What do you think the answers are, Will? You know that one of them is 1. Why do we think one of them is 1? It is a cusp. Okay, so it says what values of x are f of x not differentiable? Okay, so Will already said he knows it is x equals 1 because we are not differentiable at a cusp. Good job. All right, anywhere else? 4? Why not at 4? 4 is correct.
Because there's 2 values there. And
Well, there's a jump there, right? So the graph itself is not continuous. So x equals 4 because we are not continuous. You can say either way, yeah. All right. Anything else?
I got 8.
You got 8?
I think about 2 because it's not natural.
Okay. 8 is correct. There's still one more.
Would it be -4?
Okay, so 8 and -4. Now, I can understand the reason you said 8 is because 8's not defined, right? Yes. So neither one of them, -4 or 8. So x equals -4.
I've written down 8. I never wrote down -4.
And 8 because we are not differentiable at endpoints. Okay, so it can't be a cusp, can't be an endpoint, and it can't be somewhere that is discontinuous. All right, so example number 4. Find all the points on the graph of f of x where the fifth root of 2x squared minus 8 to the fourth for which f prime of x equals 0 and those for which f prime of x does not exist. Okay, so if you remember f prime of x equals 0, this is not necessarily pertinent to the problem, but that happens, when that happens, we have a horizontal tangent. Okay? So if it ever just said where there's a horizontal tangent, you're still looking for where the derivative equals 0. Just a vocab reminder, okay? And then f prime of x does not exist where we have a vertical tangent. All right, so let's talk about it. So before we can figure out where f prime of x equals 0, what do we have to find? Before we can figure out where it equals 0, we have to find the... We got to find the derivative. We've given f. We've got to find the derivative before we can set it equal to 0. Okay, so let's find the derivative. So f prime of x equals. All right, so again, I don't want to write it from this form. I really want to rewrite that as 2x squared minus 8 to the what power? Well, 4/5. The 1/5 is the fifth root. That part you're right. Just if there's another exponent on that function, you want to put that on as your numerator. All right. So then if we do power rule here, it's going to be 4/5 times 2x squared minus 8. All right. So 4/5 minus 1 is going to give me negative 1/5 times, what's our chain there? 4x. Okay, so the only thing I did to simplify this out is I did my 4x times my 4. Is everybody with me? So 4 times 4 gives me 16x on top. And then this is a negative, so it's going to go to the bottom. So the 5 is going to be on the bottom along with the fifth root of 2x squared minus 8. Now, the only reason I did that is because we know, okay, this entire function will be equal to 0 where which part is equal to 0? The top. The numerator is equal to 0, right? You can have a 0 in the numerator. You cannot have a 0 in the denominator. So we're equal to 0 where the numerator equals 0, right? But we are discontinuous where, right, okay? Now, so if I just set the top equal to 0, that's pretty easy. 16x equals 0, right? So that happens at 0 divided by 16 is 0. So we know we are, well, we're f prime of x equals 0 at x equals 0. So that's that part. All right, and then we're discontinuous, or we do not exist, right? Where the denominator equals 0. So I'm going to set this whole thing equal to 0. Well, what's going to happen to the 5 out front? It's going to go away because if I divide by 5, 0 divided by anything is going to be 0. All right. And then to get rid of the fifth root, I would raise it to the, okay. And when I raise 0 to the fifth power, I still get 0. So this side just becomes 2x squared minus 8 equals 0. And we're going to solve from there. So 2x squared equals 8. X squared equals 4. So x equals x equals plus and minus 2. Because he said 2, he didn't say plus or minus.
I do not like any trying to find the derivative whenever they have square root.
All right, so there's your two answers. F prime of x equals 0 at x equals 0, and it does not exist at plus or minus 2. All right, and then the last one is the easiest one of the whole day. It's a table problem. Yay! Not much calculation on table problems. All right, so they told us in the directions that h of x is f of g. They want us to find h of 0, h prime of 0, and the equation of the tangent line. Okay, so we'll get here in a minute. All right, let's just do h of 0. So h of 0 means we're going to do f of g of 0. So all I did was put a 0 in for my x's and see what's happening. All right, so look at your table. What is g of 0? It is 1. So now we're going to do f of 1, and it is 5. That's it. All right, now to find the derivative, right? To find h prime of 0, first of all, we've got to find h prime. All right, well, if we take the derivative, that's going to have to be what rule? Chain, yes. So it's going to be f prime of g of x times g prime of x. So now we can plug in our numbers. So h prime of 0 would be f prime of g of 0 times g prime of 0. All right, so g of 0 is 1, and g prime of 0 is 0.5, right? Then f prime of 1
Is 6.
and 6 times 0.5 is 3.
Dang.
All right, now, when it asks down here, find the equation of the tangent line of h of x to h of x at x equals 0, right? All right, well, pot in the sock, but you already found the pot. Correct. Yes, you already found the pot at h of 0, right? So the pot is 0, 5, correct? And yes, the slope of the tangent line at 0 was 3, so we can write our equation.
Y minus 5 equals 3x.
Good job. Thank you for not putting minus 0. I appreciate it. All right, questions, comments, concerns? We good? Review a derivative. All right. Don't forget, Delta Math is on all 3 sections due Friday. Okay.